So we are on warm-up number 68. Number 1 is graph the circle. They give you an equation. Number 2, compute the sum difference in product to give you 2 binomials. Number 3, factor by grouping. Number 4, graph f of x equals x cubed with a transformation of g of x equals 2 times f of x plus 3 minus 2. And then the last one's a system. They give us negative x plus y equals 3, negative x minus y equals 1. So, by now, like I said, it should be done, especially with number 1, being that number 1 is what we started with this module 4. Today we finished module 4. And you should know how to write that because that's file number 1 in your pop party. So by now you should know that one. But here it goes one more time. So we need to eliminate the constant. What is my constant? The 10. So you should have subtracted 10 to each side. Then grouped like variables. So that gives us x squared minus 14x, empty space, close parentheses, plus. Then we got the y squared and the negative 10y, y squared minus 10y, empty space, close parentheses, equals negative 10. So far so good? Yeah? How do we complete that square for each of those? Zachary, what do I do here?
It's 14.
Negative 14 over 2 squared, yes. And do that to the other side as well. And then?
Over 2.
Negative 10 over 2 squared. So that gives us x squared minus 14x plus 49 plus y squared minus 10y plus 25. All that equal to negative 10 plus 49 plus 25. And combined like terms on the right side, we got 49 and 25, that's 74, minus 10, that's 64. And let's factor these, might as well. So what is, how do we factor this one? Square root of the first, square root of the last, sine of the middle, squared. Square root of the first, square root of the last, sine of the middle, squared. That's your standard form equation of a circle. In case you forgot, it looks like this: x minus h squared, y minus k squared equals to r squared. Does that look familiar? Kind of, sort of? So with that, we know to get the center of the circle so that we can graph it. Tell your neighbor the center of that circle. Yeah, 7 and 5, or h and k, or our vertex if you want to call it. And then the radius, since radius squared is that means we need to take the square root of that, which is 8. And then the rest is history. We graph that using the center. The center is at 7, 5, 7, 5, and then 8 steps in each direction. So if I go 8 steps that way, I have to go over 1 at negative 1. 8 steps this way, so I'm going to be at what? Negative 3. 8 steps this way, which would be at what? 15. And 8 steps that way, which takes me to what? 13. Well, sorry. That's my tablet. Something like that, yeah? Let me round this one a little bit more. There you go, a little bit better. How we doing? Yeah? Good? Oh my goodness. Hey. All right, let's go to number 2. Sum. What'd you get for the sum, Ninel? minus 13 plus 7i. Hands, have you got that? That is correct. Remember, the I goes at the end, so for complex numbers. Jehu, difference. 3 plus 1i. Hands, have you got that? That looks about right. Pass on one.
Yeah, 28 minus 47.
28 minus 47i. Let's double check that. Multiply, that's 12i squared. Multiply, that's negative 40i. Multiply, that's negative 15i. Multiply, that's positive 40. So, combine, right here, we got 12i squared, negative 55i, and then we got plus 40. However, this is what? Negative 1. So that means negative 12 minus 55i plus 40. Combine like terms, so that gives us 28 minus 55i. All right. Number 3, factors. What'd you get for that one? Justin, pass someone.
Marco?
Marco, what'd you get?
3x plus 2.
Hands, have you got that? It's about right. Any questions? Did I make a mistake? Or yeah.
4 times 8 equals 40.
4 times 8 is 32. Thank you. Appreciate that. I did that on purpose, see if you were paying attention. 32, 32. So.
No, so the 40 is 40.
Oh. Also 32. Oh, my bad. Yeah, so this is 40. So this is right, right?
Yes.
All right, so 32. 32 minus 15 is 47? Okay, sorry. Forty-seven. Hey, let's go. Yes, Danny, go. Number 4. Graph the cubic. So now check this out, guys. Quick FYI. Every parent function has a vertex at what? 0, 0. Okay, fact number 1. Fact number 2, every parent function has the point 1, 1 in their function. So if I was to give you a linear function, it goes straight to those two. If I was to give you a parabola, guess what? It goes through those 2 points. If I was to give you a cubic function, guess what? It goes through those 2 points. Now that we know that fact, that this is what? 1, 1. These 3 parameters are going to do something to it. Talk to your neighbor, let them know what those 3 are going to do to that function. So let's start with the movement. This is going to move it what? And this one? Left. So that means my vertex would be at negative 3, negative 2. Okay, so far so good. But what is this going to do? It's going to stretch it vertically. That means instead of being 1, 1, what is the multiplier now? 2. So it would be 1, 2. So my function is going to look something like this. And now we can move it, yes? So if we move it to 3 to the left, 2 down, 3 to the left, 2 down, something like that, it's going to look something like that. And last but not least, the system. Which method did you use to solve this system? Diego. Okay, which method would you use to solve that system? Kevin, help him out. What method? subtract the x, you can't, the y. Okay, yeah, so you cancel the y's. Yeah, so that leaves us with negative 2x equals 4 divided by negative 2. So x equals negative 2. Yeah, that's called elimination, guys. Substitute that into one of the two equations. I'm going to substitute that into the top one. That's negative x plus y equals 3. But instead of x, what am I going to substitute in there? The negative 2. Negative times a negative is a positive. Then subtract 2. Y equals 1. So my solution to that system is negative 2, 1. Let's go. How are we doing? Yeah? So, problem number 1 from your pop party is going to be number 1. Graphing circles. That's the first lesson of Module 4. What was the second lesson from Module 4? Graphing parabolas, right? Vertical and horizontal. So expect some of those. From there we went into same vertical and horizontal, but with H and K. And then we went into systems, which we did yesterday and the day before. Now today I'm not going to give you the pop party today. Some people were saying during tutoring that we just need practice. Today we're going to do extra practice on systems. Copy the agenda, please. Warm up number 68. Systems of equations in 3 dimensions. We're going to continue hammering that. And for home play, I want you to get some rest from my class or act like tomatoes. Some of you need to catch up with your work. Bam. Yes? 3-day weekend. I'm going to sleep. How about that? Is that good? Yeah? Do you guys take naps, some of you? No? Like naps, what is that? What's that? Do I take naps? Oh yeah. Big time. Edwin, can you get that please? Alright, asynchronous code, no asynchronous code for today. And what's that? Tell him if I can call him back to tell you who it is, and I'll call him back. She was not. All right, thank you. All right, where was I? Oh yeah, no asynchronous code. Last night's home play. I still haven't put that on Canvas. It'll be there before 4, so make sure you upload your pictures for that. What I do want to do is go over some of the elimination process. So this is what I want us to do. Get your blank sheet of paper and copy. Anyways, just a quick recap before I go into the practice. We talked about the different ways of solving systems. There's 3 different ways: graphing, substitution. Today we're going to hammer a little bit more elimination. And then we talked about the different ways of solving quadratic equations. We talked about 3D and the graph of 3D after we practiced some of the systems. Oh, let me go back to this one. Look at that. So that was just kind of like to give you a picture as to how the 3D model might look. That look pretty cool, yeah? Yes, that's cute. All right, good. All right, so let's do this. Copy on your paper this one, please. Example 3 Shazam Q. And it just says solve the system, and as I mentioned, we're going to do that by elimination. And they give us the system 2x minus y plus 3z equals negative 12, negative x plus 2y minus 3z equals 15, and y plus 5z equals negative 6. Okay. So, if you were to do substitution, that means obviously you would use the last equation, get rid of the 5z, and make it y equal to negative 5z equals 6, and substitute that into the other two. Is that correct? But I don't want to do this with substitution. We're going to do this with elimination. So look up. If you have your highlighters or colored pens, use those. This is what we're going to do. I'm going to write first one equation. This one. I'm going to write it here. The second equation, this one, I'm going to write it over here. And under each of those, I'm going to write this third one, but aligned with the variables. Like so. So like that we can use elimination method, and you'll see it once we get there. So let's do this. So let's write the first one. The first one I'm going to write here, 2x minus y plus 3z equals negative 12. And underneath that, we have y plus 5z. Y plus 5z equals negative 6. Then again, I write the second equation, negative x plus 2y minus 3z equals 15. And underneath that again, the small one, which is y plus 5z equals negative 6. All right, this is known as elimination method because the first thing that we do is eliminate one of the variables. So I'm going to start with red. Let's look at this first one right here. They're stacked on top of each other. Which variables are going to eliminate one and another? The y, because it's y minus y, they cancel, yes? Which means we bring down what? The rest. We bring down the 2x, combine the rest. This is 3z and 5z, that's 8z. And combine this, that's negative 18. Now stop right there. Okay, so which variable did we eliminate? The y, which means over here we need to eliminate the same variable. However, here's a dilemma. Does 2y cancel 1y? No, because it's positive. So this becomes 3y. So what would this one need to be in order to eliminate the y? Negative 2y. So we need to multiply this equation, the whole equation, times negative 2. So distribute. So that gives us negative 2y, negative 10z equals 12. All right. Continue, Daniel. Go. Oh, you were waiting for me, or? We're left with negative x. The y's cancel. Negative 13z. 27. We good up to right there? All right. So now we have two smaller equations. We're going to make a system out of them. We got the first one, which is 2x plus 8z equals negative 18. And the second one is negative x minus 13z equals 27. Again, we're going to use elimination. By looking at it, which one's pretty close to eliminating? Which variable? Look at it. Which one would we eliminate? Or which one's pretty close? The x. But this one needs to be a what? And it needs to be a negative 2, right? Which means it already has a negative, so we need to multiply this times 2. Distribute, distribute, distribute. That gives us negative 2x, negative 26z equals 254. So that means we no longer use this middle one. We're going to focus on this one and this one. So, here we go. 2x minus 2x, cancel. Negative 26z plus 8z. Negative 18z, yes, equals 54 and negative 18, 36. And last but not least, we divide by negative 18, divide by negative 18, so z equals negative 2. So to finish this little system, we already solved for z. What do we need to solve for now? X. So which equation do you want to use, the top one or the green one? The top one, okay. So let's rewrite this one. I'm going to write 2x plus 8z, but instead of z, I'm going to substitute negative 2 in there. Negative 2. So this still 2x minus 16 equals negative 18. Plus 16 plus 16, that gives us, let's see, this cancels. We've got 2x equals negative 2, divide by 2, x equals negative 1. Is that correct? Yeah? Okay. So, now that we have x and z, which is the only value that we need to solve for? Y. So we go to the very beginning and pick one of the three equations. It doesn't matter which one, pick the easiest one to solve for y. Now that we have the values for x and z, which one do you want to use? The last one, yeah. Let's pick this one. So y plus 5 times z equals negative 6. Z is negative 2. So y minus 10 equals negative 6 plus 10 plus 10, y equals 4. So now that we have all three values in alphabetical order, negative 1 for x, 4 for y, and negative 2 for z. X, y, z, and these are my solutions. Woo, let's go. All right, do me a favor and look at your home plate, problem number 5. That one was problem number 5, but we did this with elimination. Check your work, see if you got something similar to that. And just for the sake of it, let's graph this, yeah? Here we go. We're going to start with y, x. Y is 4. 1, 2, 3, 4. X is negative 1. Negative 1 is over here. So that is right there. But now we have what? Z. And Z is what? Negative 2. 1, 2. So that means we need to bring this point down right there. Woo! Let's go now. Let's go. Can you guys picture it? Yeah? Kind of, sort of, yeah? Daniel, yeah? We good? Danny says he's ready for the pop party. Let's go. right. That was the elimination method. So here we go again. What is the main premise of elimination? That we start with two equations, we set them side by side, and the third one we write it underneath. Then we need to eliminate the same variable from both to make it a smaller system, solve for the two, substitute, get the last one. So with that said, let's do one more of these. Copy this one. Let's do, this one. Example 3. We're gonna call this example Q. And we're not gonna solve by substitution. We're gonna use what? Elimination. 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 Diego, you alright? You good? Alright, good. So we got the system, negative 2x plus y plus 3z equals 20. The second one is negative 3x plus 2y plus z equals 21. And 3x minus 2y plus 3z equals negative 9. Okay. So I'm going to use the three colors once more. This one in yellow, this one in green, and this one in pink. Question. In this case, do we have anyone that looks easier than the other? Not really. So at this point, you can pick two that are going to be side by side and one of them that has to be under each of the ones that we wrote side by side. So my question to you, which ones do you want side by side? The yellow and the green and the pink and the yellow, which ones? Yellow and green, okay, so the yellow one right here, the green right here, and underneath both of them, the pink one. Alright, so write those please. Make sure the variables are aligned. So here we go. Negative 2x plus y plus 3z equals 20. And underneath that we got 3x minus 2y plus 3z equals negative 9. So I use this one and that one, yeah? Over here I write negative 3x plus 2y plus z equals 21. And again, 3x minus 2y plus 3z equals negative 9. So, here goes a question. Look up to the screen. If I wanted to eliminate, let's see, look at it. Which variable do you want to eliminate? Which one? Z? Which one? Y. Okay, so to eliminate y here, what do I need to do to the top one, everyone? So let's multiply times 2. Because this one's negative 2, so this one is positive 2, yes? Distribute, 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 distribute. So that leaves us with negative 4x, positive 2y, positive 6z equals 240. We no longer use the top one. I'm going to cross this one out. And we focus on these two. So what do we get? Negative x, this cancels. 9z equals 31. Okay, so far so good. Alright? So this one we want to eliminate the y. Let's see. Can we eliminate the y? Yes. You're like, wait a minute. Wait a minute. What does that leave us with? Which is? Equals what? 12. Let's solve for z since it's already there, so divide by 4. Z equals 3. So what goes here? Negative x plus 27 equals 31. Minus 27 minus 27. Negative x equals 4. Divide by negative 1. X equals negative 4. Turn over what to do at that point. We have z, we have x. Fatima, what do you do? You substitute into one of the equations. Alright, so which one, guys? Which one? The first one? Okay. Doesn't matter? No, all of them have 3 variables, so let's use the first one. We got negative 2 parentheses for x plus y plus 3 parentheses for z equals to 20. So we got negative 4, and for z we got 3. So we have now 8 plus y plus 9 equals 20. Combine like terms, y plus 17 equals 20. So therefore minus 17, y equals 3. Solution, negative 4, 3, 3, x, y, z. Oh, x, y, z. Solution. How we doing? Yes? Kind of, sort of. How we doing? From 1 to 5? Elimination method, 4 or 5 for 5s. I think it's less extensive work than the substitution, because for substitution you need to solve one equation for a variable, substitute and then simplify, substitute to the other and simplify, and then make a system. So sometimes it eliminates pretty well like this. Okay? Alright. One last one, or we're good? One last one? Okay. Alright, so then let's go to this one. Copy this one, please. Example 3MJQ. 3MJQ. MJQ. This will be our last one. And we're going to use elimination. The system given is x plus 2y plus z equals 8, 2x plus y minus z equals 4, and x plus y plus 3z equals 7. Once again, I'm going to highlight this one in yellow, this one in green, and this one in pink. All right. So which ones do you want side by side? Which one? The first two? The yellow and pink. Okay, so let's do yellow, pink, and underneath each one of those we need the what? The green one, yeah? Okay. So here we go. The yellow one we got x plus 2y plus z equals 8, and underneath we got 2x plus y minus z equals 4. The pink one, we got x plus y plus 3z equals 7. And again, 2x plus y minus z equals 4. All right, so let's see. Start with the first two. Which variable would you like to eliminate? Let's see, everyone. Z, of course, because they're already positive and negative, so these cancel, yes? Combine the rest. This is 3x, this is 3y, and that is 12. Okay, that was straightforward. So since we eliminated z, we need to eliminate z on this one as well. Okay, can we eliminate them? No, unless we do what? Tell your neighbor, please. Erica, what do we do? Multiply times what? Three, yes, times 3. So distribute, that is 6x. Distribute, that is 3y. Distribute, that is negative 3z. And distribute, that is 12. No longer do we use this middle one anymore. We're focusing on this one and this one. All right, let's see. X plus 6x, that's 7x. Y plus 3y, that's 4y. The z's cancel. And then this becomes what? 19. All right. Let's make it into a system. 3x plus 3y equals to 12. 7x plus 4y equals to 19. Ooh, this is going to be a good one. You guys chose a good one. All right, let me move this over just to make some room. Okay, look at them. Which one can we eliminate? You're like, oh snap. Which variable? The x or the y? None of them eliminate, right? However, can we multiply this times something to make it look like this? How about this one to make it look like that, or vice versa? No. So let's think about if there was a common denominator. Which one would be the fastest to find a common denominator? This one or this one? This one? What would be our common denominator? 12. So that means one of them has to be negative, the other one has to be... So that means this one, to make it into negative 12, we need to multiply times negative 4. And this one, to make it into a positive 12, we need to multiply times what? 3. That is correct. So let's distribute this one first. So that, let's write it over here. Negative 12x, negative 3y, I'm sorry, negative 12y equals to negative 48. And then this one, we got 21x plus 12y equals to 57. Now we can eliminate, yeah? We're left with 9x what? 9. Divide by 9. X equals 1. All right, from there, Nanelle, which one do we use, the green one or the red one to substitute x in there? The green. Okay, so let's bring this one down. We got negative 12 times x, or parentheses. Negative 12y equals negative 48. We substitute in there 1, so this is negative 12 minus 12y equals negative 48. So, plus 12 plus 12, that is negative 12y equals negative 36. Last but not least, divide by negative 12, so y equals 3. And what do we do at the end? Tell your neighbors, please. Which one are we going to use to substitute? The yellow, pink, or green? Yellow? Alright, so bring the yellow down. So we got parentheses for x, so I'm using this one. Plus 2 parentheses for y. Plus z equals 8. So y we said it was 3. X is 1. So we end up with 1 plus 6 plus z equals 8. That's 7 plus z equals 8. Minus 7 to each side. So z equals 1. Solution? 1, 3, 1. X, Y, Z. Solution. Woo, let's go. From 1 to 5, elimination method, 5 fourths, 5 fourths, yeah? So kind of revisit some of your problems from the home plate, see if you can correct some of them in case you made a mistake. Alright, we'll stop right there. I'll give you some free time. Bam, let's go. Those that are watching online, once again, if you need to revisit any of the lessons, go back to them. And if you need to get the play sheet for this one, pages 190, what was it? 216, 217 are on Canvas. All right? Peace.